Hi guys, welcome back to yet another video of this chapter. In the previous video, we saw that in 10 AD, a great applied mathematician named Heron was successful in getting a formula using which we can find the area of any triangle. The formula given by Heron about the area of a triangle is known as Heron's formula. It is stated as area of a triangle is equal to under root s into s minus a into s minus b into s minus c, where a, b and c are the sides of the triangle and s is the semi-perimeter, that is half of the perimeter of the triangle. So are you still wondering how he got this formula? Well, the wait is over now. Let's see how he got this wonderful formula. First, we take any random triangle, say triangle PQR with sides A, B and C. Here, we draw a perpendicular height and name it H. So we have two right angle triangles, triangle PQM and triangle PRM. Let's take QM is equal to X. Thus, MR is equal to C minus X because the total length of the base is C. Now, as soon as we see a right angle triangle, the first thing that comes to our mind is the Pythagoras theorem. So, let's apply Pythagoras theorem in both these triangles. So, in triangle PQM, we have a squared is equal to h squared plus x squared. And in triangle PRM, we have b squared is equal to h squared plus c minus x whole squared. Let's name these equations 1 and 2 like this. Basically, what we are doing is, we are trying to find the value of h in terms of a, b and c, so that we can replace h in the formula for area of triangle which is already known to us. For that, first we will write x in terms of a, b and c. So, subtract equation 2 from equation 1. Thus we get a squared minus b squared is equal to h squared plus x squared minus h squared plus c minus x whole squared. And on solving brackets, we get a squared minus b squared is equal to x squared minus c minus x whole squared. On further solving, we get a squared minus b squared is equal to 2cx minus c squared. Now, on taking c squared to the left hand side, the equation becomes a squared minus b squared plus c squared is equal to 2cx. Now, on further solving, we get x is equal to a squared minus b squared plus c squared whole divided by 2c. Now, substitute the value of x in equation 1 so that we can get h in terms of a, b and c. Thus, equation 1 becomes a squared is equal to h squared plus a squared minus b squared plus c squared whole divided by 2c whole squared. This implies h squared is equal to a squared minus b squared plus c squared whole divided by 2c whole squared. Now we solve this equation to simplify it. So we have h squared is equal to a squared minus b squared plus c squared whole squared divided by 4c squared, which is equal to 4a squared c squared minus a squared minus b squared plus c squared whole divided by 4c squared, which can be written as h squared is equal to 2ac whole squared minus a squared minus b squared plus c squared whole squared divided by 4c squared. Now, on applying the formula, x squared minus y squared is equal to x plus y into x minus y, and further solving, we get h squared is equal to a plus b plus c into b plus c minus a into a plus c minus b into a plus b minus c whole divided by 4c squared. Now, note that a plus b plus c is nothing but the perimeter of triangle PQR. So, let's take a plus b plus c is equal to p. Thus, the equation becomes h squared is equal to p into b plus c minus a into a plus c minus b into a plus b minus c whole divided by 4c squared. Further, add and subtract a in second bracket, add and subtract b in third bracket, and add and subtract c in last bracket. And by doing so, we get h squared is equal to p into p minus 2a into p minus 2b into p minus 2c whole divided by 4c squared. This implies h is equal to square root p into p minus 2a into p minus 2b into p minus 2c whole divided by 4c squared. So, finally we got the value of h in terms of a, b and c. Remember that p is equal to a plus b plus c. So, let's substitute the value of h in the formula for area of triangle, which is half into base into height. Here, the base is c and the height is h. Thus, the area of triangle PQR is equal to half into c into under root p into p minus 2a into p minus 2b into p minus 2c whole divided by 4c squared. Now, take c and 1 by 2 inside the square root. So it becomes under root c squared by 4 into p into p minus 2a into p minus 2b into p minus 2c divided by 4c squared. And on further solving, we get area is equal to under root p by 2 into p by 2 minus a into p by 2 minus b into p by 2 minus c. Here, p by 2 is nothing but the semi-perimeter, or in simple words, it is the half of the value of the perimeter. So we take p by 2 is equal to s. Thus, s is equal to a plus b plus c by 2. So the equation becomes under root s into s minus a into s minus b into s minus c. So this is how we derive the Heron's formula, which is used for calculating the area of any triangle. Great! Now it's time we apply this formula in real-world problems to see how it works. Let's find the area of a triangular complex with side lengths 4 kilometers, 7 kilometers and 9 kilometers. Let's take A is equal to 4 kilometers, B is equal to 7 kilometers and C is equal to 9 kilometers. So that we have S is equal to 4 plus 7 plus 9 divided by 2, which is equal to 10 kilometers. Thus, the value of semi-perimeter is 10 kilometers. So, the value of S minus A is 6, the value of S minus B is 3, and the value of S minus C is 1. Now, we substitute the values of S, A, B and C in the Heron's formula, which is under root S into S minus A into S minus B into S minus C. Thus, we get area is equal to under root 10 into 6 into 3 into 1. And on further solving, we get 6 root 5. Thus, the area of the triangular park is 6 root 5 square kilometers. That was easy, right? So in case we are not given the height of a triangle and it is not easy to get it either using the given sides, we can simply apply Heron's formula to find the area of the triangle. So guys, I hope you enjoyed deriving a new formula for the area of triangles. And I hope you will practice it by solving as many problems as you can. Now, let's do a quick recap. In 10 AD, a great applied mathematician named Heron derived a formula to find the area of any triangle. Area of a triangle with its sides as A, B and C is calculated using Heron's formula, stated as area is equal to under root S into S minus A into S minus B into S minus C, where S is equal to A plus B plus C divided by 2.